Chapter I. Logic as a normative and, in particular, as a practical discipline. 4. The theoretical incompleteness of the separate sciences. It is a common experience that the excellence of an artist's mastery over his material, and the decisive certainty with which he judges and assesses works in his art, is only quite exceptionally based on a theoretical knowledge of the rules which prescribe direction and order to his practice, and determine the standards of value on which the perfection or imperfection of the complete work must be assessed. Normally the practicing artist is not the man who can inform us rightly regarding the principles of his art. He follows principles neither in his creation nor his evaluation. In his creation he follows the inner activity of his harmoniously trained powers, in his judgment his finely formed artistic taste and feeling. This is not merely so in the case of fine art, of which one may first have thought, but in that of the arts generally, in the widest sense of the word. It therefore holds for the activities of scientific creation and the theoretical evaluation of their results, for the scientific demonstrations of facts, laws, theories. Even the mathematician, the physicist and the astronomer need not understand the ultimate grounds of their activities in order to carry through even the most important scientific performances. Although their results have a power of rational persuasion for themselves and others, yet they cannot claim to have demonstrated all the last premises in their syllogisms, nor to have explored the principles on which the success of their methods reposes. The incomplete state of all sciences depends on this fact. We do not here mean the mere incompleteness with which the truths in a field have been charted, but the lack of inner clarity and rationality, which is a need independently of the expansion of the science. Even mathematics, the most advanced of all sciences, can in this respect claim no special position. Though often still treated as the ideal of all science as such, how little it really is such is shown by the old, yet never finally composed disputes as to the foundations of geometry, or as to the justification of the method of imaginaries. The same thinkers who sustain marvelous mathematical methods with such incomparable mastery, and who add new methods to them, often show themselves incapable of accounting satisfactorily for their logical validity and for the limits of their right use. Though the sciences have grown great despite these defects, and have helped us to a formerly undreamt of mastery over nature, they cannot satisfy us theoretically. They are, as theories, not crystal clear. The function of all their concepts and propositions is not fully intelligible. Not all of their presuppositions have been exactly analyzed. They are not in their entirety raised above all theoretical doubt. 5. The theoretical completion of the separate sciences by metaphysics and theory of science. To reach this theoretical goal we first need, as is fairly generally admitted, a type of investigation which belongs to the metaphysical realm. Its task is to pin down and to test the untested, for the most part not even noticed, yet very significant metaphysical presuppositions that underlie at least all those sciences that are concerned with actual reality. Such presuppositions are, for example, that an external world exists, that it is spread out in space and time, its space being, as regards its mathematical character, three-dimensional and Euclidean, and its time a one-dimensional rectilinear manifold, that all process is subject to the causal principle, etc. These presuppositions, all to be found in the framework of Aristotle's first philosophy, are at present ranked under the quite unsuitable rubric of epistemology. Such a metaphysical foundation is not, however, sufficient to provide the desired theoretical completion of the separate sciences. It concerns, moreover, only such sciences as have to do with actual reality, which does not include all sciences, certainly not the purely mathematical sciences whose objects are numbers, manifolds, etc., things thought of as mere bearers of ideal properties independent of real being or non-being. The case is different in regard to another class of investigations whose theoretical completion is plainly an indispensable postulate in our quest for knowledge, investigations which concern all sciences equally, since they concern, in brief, whatever makes sciences into sciences. This names the field of a new, and, as we shall see, complex discipline, whose peculiarity it is to be the science of science, and which could therefore be most pointedly called theory of science, with /AR. 6. The possibility and justification of logic as theory of science. The possibility and justification of such a discipline, a normative and practical discipline relating to the idea of science, can be shown by the following considerations. Science is concerned, as its name indicates, with knowing, but this does not mean that it itself consists of a sum or tissue of acts of knowing. Science exists objectively only in its literature, only in written work has it a rich relational being limited to men and their intellectual activities. In this form it is propagated down the millennia, and survives individuals, generations and nations. It therefore represents a set of external arrangements, which, just as they arose out of the knowledge acts of many individuals, can again pass over into just such acts of countless individuals, in a readily understandable manner, whose exact description would require much circumlocution. For us it is here sufficient that science provides, or should provide, certain more immediate preconditions of acts of knowing, real possibilities of knowing, whose realization by the normal or suitably endowed individual in well-known, normal circumstances can be looked on as an attainable goal of his endeavor. In this sense, therefore, science aims at knowledge. In knowledge, however, we possess truth. In actual knowledge, to which we see ourselves ultimately referred back, we possess truth as the object of a correct judgment. But this alone is not enough, since not every correct judgment, every affirmation or rejection of a state of affairs that accords with truth, represents knowledge of the being or non-being of this state of affairs. Rather we may say that, if it is to be called knowledge in the narrowest, strictest sense, it requires to be evident, to have the luminous certainty that what we have acknowledged is, that what we have rejected is not, a certainty distinguished in familiar fashion from blind belief, from vague opining, however firm and decided, if we are not to be shattered on the rocks of extreme skepticism. Common talk does not, however, stay put in this strict concept. We also speak, for example, of an act of knowing where the judgment we pass is associated with a clear memory that we previously passed a judgment of precisely the same content accompanied with inner evidence. This happens particularly where our memory also concerns a demonstrative thought process out of which this inner evidence grew, and that we are sure we can reproduce with such evidence. I know that the Pythagorean theorem is true, I can prove it, instead of the second half. One can of course also say but I have forgotten the proof. We therefore conceive knowledge in a wider, but not wholly loose sense. We separate it off from baseless opinion, by pointing to some mark of the presumed state of affairs or for the correctness of the judgment passed by us. The most perfect mark of correctness is inward evidence. It counts as an immediate intimation of truth itself. In the vast majority of cases we lack such absolute knowledge of truth, in whose place we make use, one need only think how memory functions in the above examples, of the inner evidence for a higher or lower degree of probability for our state of affairs, with which, if probability levels become high enough, a firm judgment is usually associated. The inward evidence of the probability of a state of affairs will not serve to ground the inward evidence of its truth, but it will serve to ground those comparative, inwardly evident value assessments, through which, in accordance with positive or negative probability values, we can distinguish the reasonable from the unreasonable, the better founded from the worse founded assumptions, opinions and surmises. Ultimately, therefore, all genuine, and, in particular, all scientific knowledge, rests on inner evidence. As far as such evidence extends, the concept of knowledge extends also. There is nonetheless a remaining duality in the concept of knowing or knowledge. Knowledge in the narrowest sense of the word is the being inwardly evident that a certain state of affairs is or is not, for example that S is P or that it is not P. If it is evident that a certain state of affairs is probable to this or that degree, then we have knowledge in the strictest sense of such a probability, but, in regard to the being of the state of affairs itself, and not of its probability, we only have knowledge in a wider, modified sense. It is in this latter sense, with an eye to degrees of probability, that one speaks of a greater or lesser degree of knowledge. Knowledge in the pregnant sense, its being quite evident that S is P, then counts as the absolutely fixed, ideal limit which the graded probabilities for the being P of S approach asymptotically. But the concept and task of science covers more than mere knowledge. If we live through and recognize the presence of inner percepts, singly or in groups, we have knowledge, but are far removed from science. The same applies generally to all incoherent groups of acts of knowing. A group of isolated bits of chemical knowledge would certainly not justify talk of a science of chemistry. More is plainly required, i.e. systematic coherence in the theoretical sense, which means finding grounds for one's knowing, and suitably combining and arranging the sequence of such groundings. The essence of science therefore involves unity of the foundational connections, not only isolated pieces of knowledge, but their grounded validations themselves, and together with these, the higher interweavings of such validations that we call theories, must achieve systematic unity. The aim is not merely to arrive at knowledge, but knowledge in such degree and form as would correspond to our highest theoretical aims as perfectly as possible. That we look upon, and practically strive after, systematic form as the purest embodiment of the idea of science, does not evince some merely aesthetic trait in our nature. Science neither wishes nor dares to become a field for architectonic play. The system peculiar to science, i.e. to true and correct science, is not our own invention, but is present in things, where we simply find or discover it. Science seeks to be a means towards the greatest possible conquest of the realm of truth by our knowledge. The realm of truth is, however, no disordered chaos, but is dominated and unified by law. The investigation and setting forth of truths must, therefore, likewise be systematic. It must reflect the systematic connections of those truths, and must use the latter as a ladder to progress and penetrate from the knowledge given to, or already gained by us to ever higher regions of the realm of truth. Science can never do without this helpful ladder. The inward evidence on which all knowledge ultimately reposes, is no gift of nature, appearing together with the mere idea of states of affairs without any methodically artful setup. People would otherwise never have thought of building up sciences. The longers of method would lose their sense if to intend meant to succeed. Why should one search into relations of entailment or construct proofs, if one shared in truth through immediate intimation? The inward evidence, moreover, which stamps one presented state of affairs as having real being, or the absurdity which stamps it as having no being at all, and the same, likewise, in regard to probability and improbability, is, in fact, only immediately felt in the case of a relatively quite limited group of primitive facts. Countless true propositions are only grasped by us as true when we methodically validate them. In their case, a mere regard to our propositional thought will not induce inward evidence, even if it does induce judgmental decision. Both are, however, induced, certain circumstances being normal, where we set forth from certain known truths, and tread a certain path in thought to our intended proposition. There may be many ways of establishing the same proposition, starting from these or those bits of knowledge. It is, however, a characteristic and essential circumstance that there are infinitely many truths which could never be transformed into knowledge without such methodical procedures. That this is the case, that we need grounded validations in order to pass beyond what, in knowledge, is immediately and therefore trivially evident, not only makes the sciences possible and necessary, but with these also a theory of science, a logic. All sciences proceed methodically in the pursuit of truth, employ more or less artificial aids in order to bring to knowledge truths or probabilities that would otherwise remain hidden, and in order to use the obvious or the already established as a lever for achieving what is remote and only immediately attainable. The comparative treatment of these methodical aids, in which the insights and experiences of countless generations of thinkers are stored up, should provide the means for setting up general norms for such procedures and likewise rules for their inventive construction in various classes of cases. 7. Continuation. The three most noteworthy peculiarities of grounded validations let us penetrate somewhat more deeply into this matter, and reflect on the most noteworthy peculiarities of the remarkable thought sequences called by us validations. They have in the first place the character of a fixed structure in relation to their content. We cannot, in order to reach a given piece of knowledge, that, for example of the Pythagorean theorem, choose our starting point at random among the pieces of knowledge immediately given to us, nor can we add or subtract any thought items at will, if the evidence of the proposition to be validated is to burst forth genuinely, the validation to be a genuine validation. A second point is at once evident. It might seem thinkable a priori, i.e. before we glance at, and compare instances of validation streaming in on us abundantly from every quarter that each validation should be unique both in content and in form. A whim of nature, this might at first seem a tenable thought, might have framed our psychic constitution so wantonly that our familiar talk of a multiplicity of modes of validating matters might have lacked all sense. The only thing that could be pronounced common to any validations that we might compare would be that a proposition S, itself lacking inner evidence, achieves an evident character if it appears in combination with certain known truths 1p, pi. Truths whose relevance to it is a non-recurrent matter not subject to a rational rule. This is not how the matter stands, however. A blind caprice has not bundled any set of truths 1p, pi. S together and then so instituted the human mind that it must necessarily, or in normal circumstances, connect the knowledge of S with the knowledge of 1p, 2p in no single case is this so. Connections of validation are not governed by caprice or chance, but by reason and order, i.e. by regulative laws. We hardly need an example to illuminate the point. If in a mathematical problem relating to a certain triangle ABC, we apply the proposition an equilateral triangle is equiangular, we carry out a validation which, made explicit, runs, every equilateral triangle is equiangular, the triangle ABC is equilateral, and is therefore equiangular. If we set beside this the arithmetical argument, every decimal number with an even last digit is an even number, 364 is a decimal number with an even last digit, and is therefore an even number, we note at once that the establishments have something in common, an inner constitution of like type, which is intelligibly expressed in the syllogistic form every A is B, psi so psi B. Not only have these two arguments this same form, but countless others have it as well. Our syllogistic form further represents a class concept, under which falls an infinite multitude of sentence combinations all with the constitution that this form pointedly expresses. There is also an a priori law, making any putative validation that follows this form, also actually a correct one, provided, that is, that it proceeds from correct premises. This holds in general. Wherever we ascend by an establishing argument from given pieces of knowledge to new ones, a certain form resides in our modes of validation, which is common to countless other validating arguments, and which stands in a certain relation to a general law that allows us to justify all these single validations at one go. No validating procedure, such as the quite remarkable fact, stands in isolation. None ties bits of knowledge up with other bits of knowledge, unless in their external mode of association, or in this together with the inner structure of the separate propositions, a definite type is brought out, a type which, if conceptually generalized, at once leads to a general law applying to an infinity of possible cases of validation. A third remarkable feature deserves emphasis. A priori, i.e. before one compares validating arguments in different sciences, one might think it a possible thought that forms of validation should be bound up with territories of knowledge. Though the appropriate validations do not vary with types of object, it might still be the case that they divide sharply along certain highly general class lines, the lines perhaps that demarcate varying scientific fields. Is it not the case that there is no pattern of validation common to two sciences, to mathematics, for example, and chemistry? But this too is plainly not so, as our above example shows. There is no science where laws are not applicable to individual cases, where we do not therefore have syllogisms of the form illustrated above. The same holds of many other types of syllogism. We may in fact say of all other types of syllogism that they may be so generalized, so purely conceived, as to be free of all essential relation to some conceivably limited field of knowledge. 8. The relation of these peculiarities to the possibility of science and the theory of science. These peculiarities of our validations, whose remarkable character escapes us since we are all too little disposed to turn everyday matters into problems, are visibly related to the possibility of a science and, further, of a theory of science. That there are validating arguments is not in this connection enough. If they were formless and lawless, if it were not a fundamental truth that all validating arguments have certain indwelling forms, not peculiar to the simple or indefinitely complex arguments set before us here and now, but typical of a whole class of arguments, and that the correctness of this whole class of arguments is guaranteed just by their form, if the contrary of all this were true, there would be no science. Talk about a method, about a systematically regulated progress from one bit of knowledge to another, would be senseless, and all progress would be fortuitous. The propositions 1p, 2p which were fitted to confer evident truth on the proposition s, might fortuitously come up together in our consciousness, and this evident truth would then become duly luminous. It would no longer be possible to learn anything at all from a validating argument for future use on new validating arguments with novel material. No validating argument could serve as a paradigm for any other, none could embody a type, and no set of judgments, conceived as a system of premises, could have anything typical about it which could, without conceptual highlighting or recourse to explicit inference forms, crop up, on the occasion of a new case with quite novel materials, and help us on to a fresh gain in knowledge. It would be senseless to look for a proof of a given proposition. How indeed could one attempt it? Should one try out all possible sets of propositions to see if they could be employed as premises for the proposition in question? The cleverest man would here have no advantage over the stupidest, and it may be questioned whether he would have any essential advantage over him at all. A rich imagination, a comprehensive memory, a capacity for close attention etc. are fine things, but they have intellectual meaning only in the case of a thinking being, whose validation and invention falls under laws and forms. It is generally true, in fact, that in all mental compounding, combinatory forms as well as mere elements have their associative or reproductive effect. The form, therefore, of our theoretical thoughts and thought combinations may well prove useful. As, for example, the form of certain premises makes the emergence of appropriate conclusions much easier, since former inferences of like form have succeeded, so the form of some proposition to be proved may recall certain validating forms that have formerly yielded conclusions of the same form. If this is no clear, genuine case of memory, it is none the less analogous to the latter, and to some extent latent memory, an unconscious excitation, in the sense of Beerdman. It is in any case something that greatly promotes proofs, and this not only in fields like mathematics that are dominated by arguments in form. The trained thinker finds proofs more readily than the untrained one. Why is this so? Because types of proof have been ever more deeply engraved on his mind through a varied experience, and so must operate more readily for him and determine the direction of his thought. To a certain extent any sort of scientific thought gives us practice in scientific thinking, but it is true also that to a peculiar degree and extent mathematical thought predisposes to what is mathematical, physical thought to what is physical etc. The former rests on the existence of typical forms common to all sciences, the latter on the existence of other forms, perhaps to be characterized as peculiarly structured complexes of the former, which are peculiarly related to what is peculiar to the separate sciences. The unique features of scientific flair, of anticipatory intuition and divination, hang together with this. We speak of a philological, of a mathematical flair and eye etc., and who possesses them? The trained philologist, mathematician etc., with his many years of practice. In the general nature of the objects of each realm certain forms of factual connection are rooted, these in their turn determine typical peculiarities of forms of validation that predominate in this realm. Herein we have the foundation for the pioneering hunches of science. All testing, invention and discovery therefore rests on regularities of form. If all this shows that it is regular form that makes possible the existence of sciences, so, on the other hand, it is the wide degree of independence of form from a field of knowledge that makes possible a theory of science. Were there no such independence, there would only be coordinated logic separately corresponding to the separate sciences, but no general logic. In fact both are needed, investigations into the theory of science concerning all sciences equally, and, supplementary to these, particular investigations concerning the theory and method of the separate sciences which endeavor to search into what is peculiar to them. To stress the peculiarities revealed by the comparative treatment of validating arguments, is not therefore without use in casting light on our discipline itself, on logic in the sense of a theory of science. 9 methodical modes of procedure in the sciences are in part validatory, in part auxiliary devices towards validation. Certain points must still be added, first in regard to the restriction of our treatment to validations, which plainly do not exhaust the notion of methodical procedure. Validations have, however, a central significance that will justify our provisional restriction. One can in fact say that all scientific methods which do not themselves have the character of actual validating arguments, whether simple or of any degree of complexity, are, on the one hand, abbreviations and substitutes for such validating arguments, used to economize thought, since, having themselves once and for all received sense and value from such validation, their application now in practice does the work of validation without its charge of cogitative insight. They may, on the other hand, represent more or less complex auxiliary devices, which serve to prepare for, to facilitate, to ensure or to render possible future processes of validation without themselves being able to claim a significance which is of like value with, or independent of, these basic scientific processes. To take up the latter group of methods, it is, for example, an important prerequisite for securing one's validations that one's thoughts are adequately expressed by readily distinguishable, unambiguous signs. Language offers the investigator a widely applicable sign system to express his thoughts, but, though no one can do without it, it represents a most imperfect aid towards strict research. The pernicious influences of ambiguities on the validity of syllogistic inferences are familiar. The careful thinker will not therefore use language without artificial precautions. To the extent that the terms he uses are not unambiguous and lack sharp meaning, he must define them. The definition of names we therefore see as a methodical auxiliary procedure towards ensuring validations, the latter being one's primary, truly theoretical procedures. The same is true of nomenclature. Brief, characteristic symbols for the more important, recurrent concepts are, to mention only one point, indispensable wherever the expression of such concepts, by means of one's original stock of defined expressions would be unduly circumstantial. Involved expressions with such inbuilt Chinese box complexity impede validatory operations or render them unperformable. The method of classification can be treated from similar points of view, etc. Examples of the first group of methods are provided by the extraordinarily fruitful algorithmic methods, whose peculiar function is to save us as much genuine deductive mental work as possible by artificially arranged mechanical operations on sensible signs. Whatever marvels these methods may achieve, their sense and justification depends on validatory thought. Here also belong what are literally mechanical methods. One may think of the apparatus for mechanical integration, calculating machines, etc., as well as the methodical procedures for establishing objectively valid empirical judgments, such as the various methods of determining the position of a star, electrical resistance, inert mass, refractive index, the gravitational constant, etc. Each such method represents a set of provisions whose choice and arrangement is fixed by a validatory context, which shows, in general, that such a procedure, even when blindly performed, must necessarily lead to an objectively valid individual judgment. But enough of examples. It is plain that each actual advance in science is performed in an act of validation. To this all those methodical precautions and devices relate, which logic considers in addition to processes of validation. To this relation their typical character is likewise due, which is essentially involved in the idea of method. On account of this typical character they too have a place in the discussions of the previous paragraph. I owe the ideas of theory and science as problems of the theory of science something more must be added. The theory of science, as here shown up, is not merely concerned to investigate the forms and laws of isolated validations, and the auxiliary devices which go with these. Isolated validations also occur beyond the boundaries of science, clearly, therefore, isolated validations, and loosely piled heaps of such validations, do not make up science. Science requires, as said above, a certain unity of validatory interconnection, a certain unity in the stepwise ascent of its validatory arguments, and this form of unity has itself a lofty teleological meaning in the attainment of the highest goal of knowledge for which all science strives, to advance as far as possible in the research into truth, i.e. not in the research into separate truths, but into the realm of truth or its natural provinces. The task of the theory of science will therefore also be to deal with the sciences as systematic unities of this or that sort, in other words, with the formal features that stamp them as sciences, with the features that determine their mutual boundaries and their inner articulation into fields, into relatively closed theories, with the features which fix their essentially different species or forms, etc. This systematic tissue of validatory arguments can in fact be subordinated to the concept of method, so that science's task is not merely to deal with the methods of knowledge in the sciences, but also with such methods as are themselves styled sciences. Its task is not merely to separate off valid from invalid demonstrations, but also valid from invalid theories and sciences. The task thus assigned it is plainly not independent of the one previously mentioned, but to a considerable extent presupposes a prior carrying out of the former. Research into the sciences as systematic unities is unthinkable without prior research into their validatory procedures. Both at least enter into the notion of a science of science as such. 11. Logic or theory of science as normative discipline and as technology. From our discussions up to this point, logic, in the sense of the theory of science here in question, emerges as a normative discipline. Sciences are creations of the spirit which are directed to a certain end, and which are for that reason to be judged in accordance with that end. The same holds of theories, validations, and in short of everything that we call a method. Whether a science is truly a science, or a method, depends on whether it accords with the aims that it strives for. Logic seeks to search into what pertains to genuine, valid science as such, what constitutes the idea of science, so as to be able to use the latter to measure the empirically given sciences as to their agreement with their idea, the degree to which they approach it, and where they offend against it. In this logic shows itself to be a normative science, and separates itself off from the comparative mode of treatment which tries to conceive of the sciences, according to their typical communities and peculiarities, as concrete cultural products of their era, and to explain them through the relationships which obtain in their time. For it is of the essence of a normative science that it establishes general propositions in which, with an eye to a normative standard, an idea or highest goal, certain features are mentioned whose possession guarantees conformity to that standard, or sets forth an indispensable condition of the latter. A normative science also establishes cognate propositions in which the case of nonconformity is considered or the absence of such states of affairs is pronounced. Not as if one had to state general marks in order to say what an object should be to conform to its basic norm. A normative discipline never sets forth universal criteria, any more than a therapy states universal symptoms. Special criteria are what the theory of science particularly gives us, and what it alone can give us. If it maintains that, having regard to the supreme aim of the sciences and the human mind's actual constitution, and whatever else may be invoked, such and such methods me, M2 arise, it states general propositions of the form, every group of mental activities of the sorts AB, which realize the combinatory form me, or M2, yield a case of correct method, or, what amounts to the same every, swadis are, methodical procedure of the form me, or M2, is a correct one. If one could really formulate all intrinsically possible valid propositions of this and like sort, our normative science would certainly possess a measuring rod for every pretended method, but then also only in the form of special criteria. Where the basic norm is an end or can become an end, the normative discipline by ready extension of its task gives rise to a technology. This occurs in this case too. If the theory of science sets itself the further task of investigating such conditions as are subject to our power, on which the realization of valid methods depends, and if it draws up rules for our procedure in the methodical tracking down of truth, in the valid demarcation and construction of the sciences, in the discovery and use, in particular, of the many methods that advance such sciences, and in the avoidance of errors in all of these concerns, then it has become a technology of science. This last plainly includes the whole normative theory of science, and it is therefore wholly appropriate, in view of the unquestionable value of such a technology, that the concept of logic should be correspondingly widened, and should be defined in its sense. 12 relevant definitions of logic. The definition of logic as a technology was much favored by tradition, but closer determinations of it left much to be desired. Definitions such as technology of judgment, of reasoning, of knowing, of thinking, /art depensa, are misleading, and in any case too narrow. If we restrict the vague meaning of the word thinking in the last mentioned definition, in use to this day, to the concept of correct judgment, our definition reads, the technology of correct judgment. But that this definition is too narrow is plain from the fact that the aim of scientific knowledge does not follow from it. If one says that the aim of thinking is first perfectly fulfilled in science, this is without doubt right, but it concedes that not thought or knowledge is really the end of the technology in question, but that towards which thought itself is a means. Other definitions are open to similar objections. They are open to the objection recently revived by Bergman that the technology of an activity, for example painting, singing, writing, would be expected above all to show what one must do to perform the relevant activity correctly, for example how one must hold and wield the brush in painting, how one must use the chest, throat and mouth in singing, how one must pull and relax the reins in riding and press with one's legs. This would admit into the field of logic doctrines wholly alien to it. One Schleiermacher's definition of logic as the technology of scientific knowledge certainly comes closer to the truth. For obviously in a discipline so defined one would have to consider only what is peculiar to scientific knowledge, and to probe its possible demands. The further preconditions which in general favor the emergence of knowledge would be left to pedagogy, hygiene etc. But Schleiermacher's definition does not plainly say that this technology should also set up rules for the demarcation and construction of the sciences, whereas this aim, on the other hand, includes the aim of scientific knowledge. Excellent thoughts towards the circumscription of our discipline are to be found in Bolzano's Wissenschaftsführer, but rather in his preliminary critical searchings than in the definition he himself espouses. This last sounds oddly enough. The theory of science, or logic, is the science which shows us how to present the sciences in convenient textbooks. 2.